David Smith here with yet one more Flipped Classroom math lesson. 3 tips before we start. First, you can adjust the playback speed to suit you. You can also pause a video at any point and jot down notes or write down questions for our next class. Lastly, you can turn on the captions and read my words on the screen. So today we're going to explore compounding more frequently than every year. And this is how life works. This is how banks pay you interest. And we're going to look at the equation that allows you to do that. But first, I want to remind you that in our last lesson, we used the geometric sequence approach towards figuring out compound interest. There is a more straightforward way to do that, and that's this equation here. This is for annual compounding, and we just have new variables, future value, present value, 1 plus r expressed as an interest rate divided by 100 to the number of years. This is way more straightforward than the geometric sequence approach, so I recommend that you use that. And that equation is in your IB formula booklet. Okay, so let's get started. So here's the equation for compounding more frequently than yearly. So we have future value, present value. So the present value is the amount of money you throw in the account. The future value is what you have after a certain amount of time. So future value, present value. R is the interest rate. And with the interest rate, you want to put this in as a percentage. So if it's 2.9%, then what you do is you put 2.9% in for R, 2.9, okay? And then K is the number of times it's compounded per year. So if it's monthly, K would be 12. If it's quarterly, K would be 4, because that's 4 times a year. So that will change depending on the frequency of compounding. Finally, N is the number of years. So what you have here is you have the interest rate divided by K, which is the number of times compounded per year, times 100. And then you raise it to the power of, again, the number of times compounded per year times the number of years. So let's do an example and you can see how this works. We're going to invest $5,000 at 2.5% with quarterly compounding. Okay? So you're going to find this calculation is pretty straightforward. We want to know how much is in the account. Let's say how much after 5 years? We need our N. Okay, so future value. We don't know that yet. FV, future value. Present value, that's what it's worth now. So that's 5,000 times 1 plus 2.5% over, what's our K with quarterly compounding? It's 4, because that's 4 times a year. So 2.5 over 4 times 100, close parens. Now we want to put our Kn up there. K is 4, and then we're doing it for 5 years. So that's K 4 times 5. Okay? So go ahead and do your calculation, pull out your calculator, and see what you get for that. All right, let's see how you did. When I put this in, this is what I get, $5,663.54. Okay? So now let's do some comparisons. How about monthly compounding? So what I want you to do is pause the video and do that math. Okay, so do your plug-in step with monthly compounding, calculate it all the way through, and see what you get. Okay, here's my plug-in step. Really, the only thing that changed is instead of quarterly compounding, which is 4 times per year, now we put 12 for monthly compounding, which is 12 times a year. Okay, here's what I get, 566,501. Not a huge improvement, couple bucks more, actually not even quite a couple bucks more, but let's do daily compounding. And this is what you get in reality. Or if you don't pay attention, your bank might not give you daily compounding, but that's what you want. So every day, the interest earned for that day gets added to your account, and the next day, that interest that you previously earned is now earning interest for you. That's compound interest. Okay, so do daily. Go ahead and do your plug-in step for daily, do your calc, and see what you get. Okay, here's my plug-in step. And again, the only change I made was to K. Everything else in this calculation is the same. So now my K went to 365 for 365 days, and I put 365 there. Now, if you want to account for leap year, remember leap year, we add a day every 4 years, so you can use 365.25. I will take either one on a test or quiz. Okay, so here's what I get here. Notice how we only added 70 more cents for going from monthly to daily. So as we compound more and more frequently, the return we get is less and less. Okay, so let's do one more calc here just to compare fully. Go ahead, pause the video, use this equation to calculate annual compounding. Okay, so here's my plug-in step. What you had to realize was K is 1 in this case. So I actually used this equation. If I use this equation, then there's no K. Either way, what I get is 5,000, and this is actually, let's just do it that way. This is going to be 100, and this is going to be 5. Let's use the correct equation. So go ahead and put that in your calculator, see what you get. Okay, what I get is $5,657.04. So that's our lowest return for annual compounding. Now, maybe we should just check out simple interest as well. So let's just check that out. So simple interest, we don't use this equation. We just find out what our common difference is. So let's just squeeze that in over here. Simple interest. So what's our interest? What's 2.5% on 5,000? That's going to be 5,000 times 0.025. So what I get is 125. So we're going to add 125 5 times. So it's going to be 5,000 plus 5 times 125. So 5 times 125 is 625. So that's $5,625 even. Okay? So that's the lowest return. And notice how if we go to daily, we've got 5,665. Here we've got 5,625. So we're making 40 more bucks over 5 years. So that's significant. And then remember, if that account was 50,000, then we'd be making $400 more dollars. So when you look at that, this really points out that when you're investing your money or putting it in a savings account or in some kind of instrument that earns you a fixed rate of interest, you want daily compounding. Okay, so here's a different wrinkle on this type of a calculation. Okay, so check her out. We're investing $80,000 at 3% per annum. Now remember, per annum means per year. It's just a Latin word per year. Our book likes to use annum, so just remember that. And we're doing quarterly compounding in this case, okay? So the question is, how long does it take for the investment to double? Okay, so think for a minute, what are you going to do with your plug-in step to calculate that? Okay, so double means we're looking for this amount to go to 160,000. So we're going to set 160,000 as our future value. That's what we're looking for. So that's 160,000, and that's going to equal 80,000 times 1 plus our interest rate, which is 3%, over K times 100. So what's K with quarterly compounding? That's 4. So that's over 4 times 100. And then that's raised to what power? We don't know N, okay? But we do know K. K is 4. So it's to the 4N power. Now it's going to take a little bit of doing to get that solved, but we'll get there. Okay, so now that we have the plug-in step, let's rearrange that equation a little bit. Let's simplify it down. So go ahead, pause the video and do that. Okay, so here's the simplified version. First thing I did is I divided through by 80,000, which just gives me 2, which actually kind of makes sense because we're looking for the investment to double. Okay, so that's where the 2 shows up. And then I just did what was inside here, and that gives us 1.0075. I left my 4n there. Okay, so now we've got an equation we need to use logs to solve, and I put up the log equations here, and I want to point out that I had these reversed in the last video, so apologies. When you have b equals a to the x, you get log A. So that's the base in the log, and that's the base of the power. So that kind of makes sense that way. So log A of B equals X. So go ahead, pause the video, and write the correct log equation to solve this one for 4n. That's our variable, that's our X. Okay, so here's the correct log equation. It's log to the base 1.0075 of 2 is going to equal 4n. So go ahead and solve that one. Okay, so when I put this into my fancy schmancy calculator, what I get for log base 1.0075 of 2 is 92.77. Now that equals 4n, so I've got to divide through by 4, and what I get is 23.2 years for this $80,000 investment that's invested at 3% for that to double. Now that you've watched the video, take a moment to write down some notes or questions or a short summary of the lesson. You can also re-watch portions of the video that you didn't get so well the first time. If you enjoyed the video, please click like. If you'd like to help me grow my YouTube channel, please click subscribe.